So this is section 8.5, partial fractions, part 2. Now last time we kind of spent a lot of time talking about the algebraic part of these problems, doing the partial fraction decomposition. And so now we're going to apply that technique to definite integrals and indefinite integrals as we get back into the calculus part of this. So what we're going to do is we want to integrate 5x minus 1 over x squared minus x minus 2. Now your first thought should be, well, what if that denominator is u? Well, its derivative 2x minus 1 be exactly what I need up on top to make that my du. No, it's 5x minus 1. Unfortunately, that is not correct, and it can't be made to be correct. So that's not an option. So what we're going to do is we're going to settle on saying, well, maybe we can use partial fraction decomposition. So we're going to go over to the side and do a lemma. And when I write this, I generally start out by doing the factoring as I'm moving over here, so I don't have to write an extra line. So the factors of -2 that add up to be -1 are -2 and +1. And this is the easiest type, where you get two linear factors like this. This is the type where you can actually use what I used first last time, which was, making up values of x to solve for one of the variables. Okay, I'm going to multiply both sides of this equation by my LCD, which is x minus 2 and x plus 1. On the left, cancels both. On the right, for the first fraction, the x minus 2 cancels, leaving a times x plus 1. And multiplying both of those by the second fraction cancels the x plus 1, leaving b times x minus 2. And like I said, this is the type where you want to use that shortcut instead of having to form the system of equations, which you could do with this one. This is just easier when it can be done. This is what you want to do. So if I let x equal -1, 5 times -1, -5 minus 1 is -6. -1 plus 1 is 0, so the a term is gone. -1 minus 2 is -3, so that's -3b. And then dividing, I find that b is +2. Then I might want to let x equal 2. On the left, 5 times 2, 10 minus 1 is 9. 2 plus 1 is 3, so 3 times a, plus 2 minus 2 is 0, so that term will be 0, which means we can solve for a, and it's 3. So we take that information up here to say that this is now known to be 3 over x minus 2 plus 2 over x plus 1. You have to be very careful that you don't accidentally switch those and make it 2 over x minus 2 and 3 over x plus 1, because that is not the same thing. So you'll be committing a really bad error if you make that mistake. So we got, as a substitution from our lemma, we know that that decomposes into 3 over x minus 2 plus 2 over x plus 1 dx. And as we talked about early in that section before, this will be 3 times 1 over x minus 2 dx plus 2 times the integral of 1 over x plus 1 dx. And these are easy integrals to do. That's the natural logarithm of the absolute value of x minus 2 plus 2 times the natural logarithm of x plus 1 plus c. So you might recall earlier we had developed formulas for like the integral of sine of kx dx. To make that faster, we knew that the antiderivative of sine is negative, and it will end up being 1 over k cosine of kx, which you can prove using U substitution. And likewise, cosine of kx dx is 1 over k sine of kx plus c. I'm not sure we talked about this one, but this one's easy as well. We have e to the kx dx. Thinking of U substitution, we'll have to introduce a k, so 1 over k e to the kx plus c. And if you need to go off to the side and prove to yourself using U substitution that those are true, I suggest that that's a good idea. And if we have anything that looks like this, k over x minus a dx. Again, you could prove this to yourself using substitution, where u is x minus a, you pull the k out in front, etc., etc. And that's going to be k times the natural logarithm of x minus a plus c. And if you know these shortcuts, it really makes the end of a lot of these problems super easy. There's another possibility that I want to mention, and I'm going to show you the development of this one. I'm not going to assume anything about your ability to just understand this with just a waving of my hands and a statement that is true. I'm going to prove this one using U substitution. So if I let u equal mx minus a, then du is equal to m times 1 minus 0 times dx, where and these m and k and a are always some constant. I probably should have said that. I just forgot. Okay, so our du needs not only the dx, which is essential, it also needs that m. So I'm going to multiply by m, which means outside and front I'll have to multiply by 1 over m. And I'll pull that k out, which makes it k over m. What's left inside will be 1 over mx minus a, which is 1 over u. And the dx and the m are my du. And so this is k over m, natural logarithm of the absolute value of u, plus c, which is k over m, natural logarithm of the absolute value of mx minus a plus c. So here's the final version of that rule. If you have a constant k over a constant mx minus a constant a dx, this is a shortcut for its antiderivative. Now, if you don't feel comfortable memorizing these, or don't think that you want to waste your time, if that's the way you feel, memorizing them, that's okay. You can always do the U substitution every time and arrive at the right answer. I'm not saying you can't do that. Just saying that for some of you, you would like to know a shortcut, and here it is. And so that's how I was able to do these two so easily. 3 ln of absolute value of x minus 2 plus 2 ln of absolute value of x plus 1. So I did want to say that at this point so that you'd realize that that set of shortcuts we're developing is really handy. Okay. So, oh, and by the way, looking at our answer. No, that's fine. I'm going to leave it alone. All right, so that's good. Let's do this one. Find the antiderivative of 2x cubed minus 4x minus 8 divided by x squared minus x times x squared plus 4 dx. I'd like for you to try this one, so put me on pause and see if you can do this one by yourself. Okay, so let's see how you did. First of all, I hope you saw, this wasn't supposed to be a trick question per se, but that denominator was not completely factored. And you want to make sure it is completely factored before you get started. Otherwise, you're going to have to do the process a second time for the thing you forgot to factor. The first factor in the denominator has a common factor of x, leaving x minus 1. X squared plus 4 is prime. It does not factor. The difference of two squares factors, but the sum of two squares is prime. So hopefully that did not mess you up. All right, so go over to the side and do a lemma to decompose this into partial fractions. So 2x cubed minus 4x minus 8 over x times x minus 1 times x squared plus 4. So we're going to have a fraction with each factor in the denominator now as its own denominator. So we'll have a fraction with the denominator of x. Since that's linear, we'll have a constant numerator. Plus, next fraction with x minus 1 as the denominator. Since that's a linear factor, we'll have a constant numerator. Then the last one is a quadratic denominator, x squared plus 4, which means we have to allow for a linear numerator. So cx plus d. So multiplying both sides of this equation by the common denominator, the left side, the denominator pieces will all cancel out, leaving the numerator. Multiplying the three factors in our denominator by our first fraction, the x will cancel, leaving a times x minus 1 times x squared plus 4. I can see that I'm going to bleed over to the right a little bit, so I may need to move over. You'll see in a second what I have to do. Okay. Then the second fraction multiplied by those three factors, the x minus 1 will cancel, leaving b times x squared plus 4. Plus, then those three factors multiplied by the third fraction leaves cx plus d. The x squared plus 4 does cancel, leaving the x and the x minus 1. Okay. So I know this is one where you probably are thinking, well, we're going to need to do the system of equations, and a lot of times that's true. I'm going to try this one and show you that sometimes a hybrid of the two ideas is actually worth knowing how to do. So it's not going to get every answer, but we're going to get at least some of the answers. So I think a good number to let x equal would be 1, because it's going to make the x minus 1 equal to 0. So on the left side, 2 times 1 cubed minus 4 times 1 minus 8 is negative 10. equals, the right side will be 0, plus 1 times 1 plus 5 is 5, so that'll be 5b. And the last term will also be 0. So we can solve for b, and it's -2. There's nothing I could put in for x that would make x squared plus 4 equal 0, at least no real number. So I can't make that one, so that's why I know in my head I'm going to have to do something more than just this. But notice we did get at least what b is. Now another thing I might let x equal is 0. So on the left side, 2 times 0 cubed minus 4 times 0 minus 8 is -8. On the right side, 0 minus 1 is -1. 0 squared plus 4 is 4. -1 times 4 is -4, so that's -4a. Plus, the next term will be 0, and the third term will be 0. So we can solve for a, and we get +2. Now, there's really no substitution that will directly give me C or D, but I do know A and B now, so that's actually good news for us. So if you just have 1 or 2 left to go, like this, you can continue and just pick some other values for x. I'm not going to do it on this one. Or you can go back and do the system of equations, but this should be a little bit easier because we now know what a and b are. So using those values, 2x cubed minus 4x minus 8 will equal 2 times x minus 1 times x squared plus 4, which will be x cubed minus x squared plus 4x minus 4 plus b, which is -2, times, I'm distributing the x cubed plus 4x plus cx squared plus dx times x minus 1. So we will have fewer things that we need to find using the system. So that's why finding a few of them up front like this, using a hybrid of the pick a nice number for x so that some things go away so you can solve for a letter, coupled with the idea of the system of equations. So I'm distributing the 2. I'm going to distribute the -2. And do the multiplication over here. That's cx cubed plus dx squared minus cx squared minus dx. Okay, so you might notice in this particular problem that this and this combine to be 0. So the only other cubed term is cx cubed, sorry, which has to equal 2x cubed. So c has to be 2. So that's pretty nice to know. Okay, so the negative 2x squared plus dx squared minus cx squared will have to equal, there aren't any x squared on the left side, so it will have to equal 0. So negative 2 plus d plus, I'm sorry, minus c. Oh, but I don't need to write c because I already know what c is. We already know that c is 2, so instead of writing minus c, I'm going to write minus 2 has to equal 0. And that means we can solve for d. D is 4. It's a d. Okay, we should double check because that's everything we needed to know, a, b, c, and d. Let's just double check that everything else works out correctly. 8x minus 8x minus dx, which would be minus 4. Is that equal to negative 4? And it is. So that checked out. And then the constant, there's only one. The constant on the left is negative 8 equals the constant on the right, which is negative 8. So yeah, that worked. All right, so that means that our original problem, 2x cubed minus 4x minus 8 over x times x minus 1 times x squared plus 4 is, after all that work, equal to a, which was 2, over x, plus b, which is negative 2, over x minus 1, plus c, which is 2, times x, plus d, which is 4, over x squared plus 4. That's how that decomposes. Okay, so now we get to go back to the calculus problem with all of that. All right, so let me see if I'll be able to see that over here. If I move, no, it's not going to be easy to see. Well, I'll just have to punt. I can almost make it out. Okay. Well, I'll do my best. I want to be able to see it while I'm writing. Okay, so this integral over here after partial fraction decomposition is equal to 2 over x minus 2 over x minus 1 plus 2x plus 4 over x squared plus 4. Dx. Okay, I'll move this back over a little bit so I can see what I'm doing. Okay, I think that's fine. So I'll move a little bit more to the left so I have more room. This lemma needs to be kept separate. All right, so the first one I can do. That's going to be 2 times the ln of the absolute value of x. Easy peasy. The second one's easy. Minus 2 times the ln of the absolute value of x minus 1. The next one, if I tried to let u equal x squared plus 4, du would be 2x dx. And that's not exactly what I have, but what I can do is something we talked about earlier, is that can be split in. This third fraction can be split into two pieces. 2x over x squared plus 4. I'm going to go ahead and split that into two integrals. Plus 4 over x squared plus 4 dx. Okay, so the first few things were done. So I'm just copying those down. So for this next one, we actually sort of started the thought process. If u is x squared plus 4, I guess I can write it up here in case you need to see what I'm talking about, then du is 2x dx, which is exactly what I have. And so that ends up being 1 over u du, which is the natural log of the absolute value of that u, which is x squared plus 4. Plus, this next one, if I pull the 4 out, I hope that you would recognize this. This is one of your basic 20 that you're supposed to know how to do. So I've got to copy the first part again, so I didn't go straight to the answer yet. There we go. Oh, and by the way, x squared is non-negative. If I add 4 to a non-negative thing, it's definitely positive. So those absolute value are technically not necessary. So this last one is, again, I should probably memorize these numbers for your sake. It's one of the last three, 18, 19, or 20. It's the inverse tangent one, where u squared is x squared, so u is x, du is dx, which we have, and a squared is 4, which means a is 2. And so what we get is the 4 that's out front times 1 over a, arctangent or inverse tangent of u, which is x, over a, which is 2, plus c. Almost didn't get that squeezed in. So our final answer, the first part of which we've carried down because it's been done for a while, is 2 ln of the absolute value of x minus 2 ln of the absolute value of x minus 1 plus the ln of the quantity x squared plus 4 plus 2 inverse tangent of x over 2 plus c, which is our final answer for that one. Okay. So that's that leads us to the statement about quadratic factors, which I think I've covered all of that. So you can read through it and find out, oh yeah, that's what we talked about earlier. So now let's go to the next example. Move this down. So let's look at another example. This is example 4, part A. Integrate x squared plus 8x minus 2 divided by x cubed minus 3x minus 2 dx. Okay, my first thought would be, can I let u equal the denominator? If I do that, the derivative will be 3x squared minus 3, which is not the numerator, so that's not going to work. So I'm going to try to see if partial fraction decomposition will work. So x squared plus 8x minus 2. And then factoring that cubic polynomial, I get x minus 2 times x plus 1 quantity squared. And if you do not know how to factor that yourself, that'd be a great question to ask in class. Be happy to answer it. Okay, so that's going to decompose into a over x minus 2 because it's linear. The numerator is a constant. Then we have a repeated linear factor. So we're going to have a constant over x plus 1 squared and use every power of x plus 1 down to 1. Of course, we're at 2, so that's not very far to go to have x plus 1 to the first. Then multiplying both sides by the common denominator. The x minus 2 would cancel on the first fraction, leaving a times x plus 1 squared. The next one, the x plus 1 squared would cancel, leaving b times x minus 2. And c times x minus 2 times the one x plus 1 that did not cancel. One of them did, the other one's still there. And so x squared plus 8x minus 2 well, hold on. I'm gonna change my mind. I was about to do the matrix way with this one, but I think I'm gonna try that hybrid and see if that's going to get us there. Let's let x equal -1 to start with. So -1 squared is 1, plus 8 times -1 is -8, 1 minus 8 is -7, minus 2 is -9. The a term will go away, as will the c term. Those both turn into 0. So the b term is -1 minus 2 is -3, so that's equal to -3b, which means that b is positive 3. Okay, then I might let x equal positive 2. So 2 squared 4 plus 2 times 8 is 16, is 20, minus 2 is 18. The first term, 2 plus 1 is 3 squared, is 9, so that'll be equal to 9a. Substituting in 2 for the next two terms will make them 0, so we can solve for a, and it's 2. Now this time we only have one left to go. So instead of substituting b and a into that equation, if you only have one to go, and notice with 2 and -1, that c term for those is never going to be still there. So if you only have one to go, let x be anything. And I like 0 because it's easy to substitute. Anything you haven't already used. And so 0 squared plus 8 times 0 minus 2 is -2 on the left. 0 plus 1 is 1. 1 squared is 1. 1 times a, which we know is 2, is 2. 0 minus 2 is negative 2. Negative 2 times b. And since b we know is 3, negative 2 times 3 is negative 6. And then 0 minus 2 is negative 2. 0 plus 1 is 1. Negative 2 times 1 is negative 2. Negative 2c. And solve that equation for c. So let me see. C would equal negative 1. Just want to double check that. Yeah, that's right. Okay, so that means that this integral can be thought of as the integral of a, which is 2, over x minus 2, plus b, which is 3, over x plus 1 squared, plus c, which is negative 1, over x plus 1. dx. Okay. So, integrating, we will get 2 ln of the absolute value of x minus 2. Be very careful. You've been doing this for a while, and so you're going to think everything is a natural logarithm. But keep in mind, this is actually 1 over u squared, well, with a 3 out in front. And so keep in mind that to do that, that's u to the negative 2 du. And that is u to the negative 1 divided by negative 1. So please keep that in mind. That's why this will be minus 3 over x plus 1 to the first. And this will be minus ln of the absolute value of x plus 1 plus c. All right. All right, so let's look at problem B. This is the integral of x cubed plus 7x squared plus 9x plus 15 all over I see that that's not completely factored. So I'm going to go ahead and factor it here. Factor out that common factor of x times x plus 1 times x squared plus 5 dx. All right, so here's our lemma. So that being in factored form, I'm ready to go ahead and get started. So our numerator over our factored denominator So this will be a over x plus b over x plus 1 plus cx plus d over x squared plus 5. So multiplying both sides by our LCD on the left side will give us back our numerator. And multiplying the common denominator by the first fraction, the x cancels, leaving x plus 1 and x squared plus 5. Multiplying the second fraction by our common denominator cancels the x plus 1, leaving the x and the x squared plus 5. And multiplying our LCD by the third fraction cancels the x squared plus 5, leaving x times x plus 1. Alright, so on this one, I'm going to multiply things out on the right hand side. So that's going to be a x cubed plus ax squared plus 5ax plus 5a plus bx cubed plus 5bx plus cx cubed plus dx squared plus cx squared plus dx. So let me double check, make sure I got everything right. Well, it sure is bad to go forward at this stage if you've made a mistake. Okay, I think everything looks good. So here we go. Let's start with the x cubed terms. A plus b plus c has to equal the coefficient of x cubed on the left, which is 1. Okay, next, let's do the x squared terms. So we have a plus c plus d. I know I put those out of the order in which they appeared, but I wanted everything to be in the same order. A, B, C, D equals number is my idea. Okay, so I think I got all those, and that's supposed to equal the number of x squared on the left side, which is 7. Okay, let's do the x's. So we have 5a (5b) plus d equals the number of x's on the left side, which is 9. And then finally, the constants. 5a. Oh, that is the only constant. Equals 15. And you can go ahead and solve for a here if you want to. It's not a problem. But because this is 4 variables with 4 unknowns, I really don't want to solve this system any other way than with an augmented matrix and a calculator. So we can double check. We know a is 3, and if we get something other than 3 when we set this up, we'll know we made a mistake someplace. Okay, so we're going to do the reduced row echelon form of the matrix that is 1a, 1b, 1c, 0d. Next line, 1a, 0b, 1c, 1d. Next line, 5a, 5b, 0c, 1d. And then 5a, 0b, 0c, 0d. Then we're going to augment that coefficient matrix with our constants, 1, 7, 9, 15. You're going to type that in your calculator as we did last time and record the result. Oops, need to go down a little bit. Got to the bar at the end there. That's not what I wanted to do. Okay, so straight dot there. Rid of it. All right. So when you do this in your calculator, you should get 1, 0, 0, 0, 3. No big surprise there. That means a is 3. 0, 1, 0, 0, negative 2. 0, 0, 1, 0 is 0. And 0, 0, 0, 1, 4. And then we need to interpret what that means to get that answer. That means that A is 3, B is negative 2, C is 0, and D is 4. Okay, so that is our lemma. Now let's go back over to regular problem and pick up with that. So that means that that integral is equal to a over x, so that'll be 3 over x, plus b over x plus 1, plus negative 2 is going to be minus 2 over x plus 1, plus 0x, because c is 0, plus 4, because d is 4, that ends up being 4, over x squared plus 5 dx. Okay, so that's 3 ln of the absolute value of x minus 2 ln of the absolute value of x plus 1 plus 4 over a, which is square root of 5, tangent inverse of u, which is x, over a, which is square root of 5, plus c. And that's one that we had done just pretty recently with that inverse tangent. So that one should not be that big of a surprise that we can do that now, having done a few of those rather quickly. The only thing is I want to clean that up. So that'll be 4 square roots of 5 over 5 inverse tangent of x square roots of 5 over 5 plus c. Okay, so let's go down and look at the next one we're going to do, c. Alright, so this one is the integral of 3x cubed minus x squared plus 8x plus 2 over x squared plus 3 quantity squared dx. Okay, put on pause and see what you can do with this one, and then come back in a second and we'll see. Alright, so x squared plus 3 is prime, and so when we come over here, that is completely factored as it is already. So since we have a repeated factor, we're going to have to use every power of that from what it is down to first power as we set up our partial fractions for decomposition. So we're going to have x squared plus 3, which is a quadratic factor, which means we have to have a one less power numerator. So if it's x squared, the numerator is going to have linear x to the first, so that we would call this ax plus b. Should move this over so we can see it better. Okay. And then the second denominator is the next lower power of x squared plus 3, which happens to be to the first, so that's the last one we'll have to write of those. Since it's a quadratic factor, it'll have to have a linear numerator, so cx plus d. So multiply both sides of the equation by the LCD, the least common denominator, of all the fractions in this problem. On the left side will cancel out the denominator completely. When you multiply that by the first fraction, the denominator gets canceled completely, leaving ax plus b. And then multiplying the LCD by the third fraction, the very last fraction, cancels one of the x squared plus 3, leaving the other one still there. And so 3x cubed minus x squared plus 8x plus 2 equals ax plus b plus cx cubed plus cx, oops, sorry, messed that up, back up a little bit, cx cubed plus 3cx plus dx squared plus 3d. All right. So let's look for the cubic, or the cubes on x. We have c, and that's it. That has to equal the coefficient of x cubed on the left side. So c is 3. Well, that's kind of nice and fast. X squared. Well, I have one of those. D has to equal the coefficient of x squared on the left side, which is -1. That was fast. I like these. It's getting pretty easy. Whoops, I forgot to do something. There we go. Gotta be consistent here. So the x's, I've got a plus 3c, but since we already know what c is, I'm going to go ahead and substitute for that, plus 3 times c, which is 3, so 9. Okay, that's all of the x's. That needs to equal the coefficient of x on the other side, which means we can get a pretty quickly. It is -1. And then finally, the constants b plus 3d. Of course, we know what d is. It's -1. So 3 times -1 is -3. And that has to equal the constant on the left side, which is 2, which means we can solve pretty quickly for b, and it is 5. Okay, let's go back over here and up. Take our result. Oops, went too far. Sorry about that. Not quite that far. There we go. Got to center this a little bit better so you can see. All right, so that means that this integral, oops, not the color I wanted. This integral becomes, excuse me, the opposite of x plus 5 over x squared plus 3 quantity squared plus 3x minus 1 over x squared plus 3. Okay, so to do this problem, I am going to split the fractions into 2 parts each. So, for example, I'm going to have -x over x squared plus 3 squared dx plus the integral of 5 over x squared plus 3 quantity squared dx plus the integral of 3x over x squared plus 3 dx minus 1 over x squared plus 3 dx. Okay, so pause the recording and see if you can finish it now. Okay, hopefully you were able to make some headway with this one. Okay, so for the first one, I guess I'm going to color code these. So this will be pink. For the first one, if I let u, hold on, let me make sure I'm doing this the way I want it. Yes, if I let u equal x squared plus 3 du is 2x dx. So I'm going to have to multiply inside by 2 and outside and front by 1/2, so that I'm multiplying by a form of 1. And that becomes 1/2, well, negative, because I'm going to pull that negative out in front as well. Negative 1/2, 1 over u squared, and the negative, and the 2 and the x and the dx all become the du. And I'll rewrite that 1 over u squared as a power of u to the negative 2. Notice that I'm sticking with this one until I'm done. When you have 4 different parts, sometimes that's the best thing you can do, because you don't want to get distracted with a different thing and mix one thing up with another. So the antiderivative of u to the negative 2 is u to the negative 1 divided by negative 1. And we will have a plus c, but I'm not going to worry about that just yet. I'll put that after the 4th one is done. And so this becomes positive 1 over 2u and keeping track of what u was used, and that's why the color coding will help me a lot. This becomes 1 over 2. Oops, well, it's an answer, but I want it to be color coded. I forgot to change colors, so sorry about that. 1 over 2 times u, which was x squared plus 3. Okay. So that's 1. Both of them. 3 to go. All right, now for the second one. This one right here. Let's see, what technique can we use for that? Well, I'm going to need to do another lemma. That was lemma number 1. Because the second one is rather complicated. So I'll go off and do lemma number 2 now. Do it over here to the side. Yeah, I've got room over here. Okay, so this is lemma 2. So I'm going to start by pulling that 5 constant out in front, so I can focus on this. And even though it's not a square root, this actually will fit with the trig substitution idea, where we have u squared is x squared, so u is x, and a squared is 3, so a is square root of 3. And that means that x, which is our u, will be a. Remember, the trig substitution we do with the sum is let it be a tangent theta. Almost didn't get that squeezed in. So that means that dx is going to be the square root of 3. The derivative of tangent is secant squared theta d theta. Okay, so this is 5 times the integral of 1 over our x squared, since x is square root of 3 tangent of theta. The square of that will be 3 tangent squared theta. Oops. A little stray mark there. I don't want you to think of something important. 3 tangent squared theta. Okay, plus the 3 that was already there. Quantity squared times dx, which is square root of 3, secant squared theta d theta. So I'm going to bring that square root of 3 out in front. And I'm going to factor out the 3 from both the tangent squared and the 3, which makes that tangent squared theta plus 1, quantity squared, times secant squared theta d theta. Okay, well, if we distribute that squaring to the two factors, I'll be having to square 3, which is 9. I'm going to pull that constant out in front, and that 9 is in the denominator. That would leave me with tangent squared plus 1, which is the same thing as secant squared theta, quantity squared, times secant squared theta d theta. And I can cancel one of those secant squared in the denominator with the one in the numerator, leaving a single secant squared theta in the denominator. And I can use a reciprocal identity. Reciprocal of secant is cosine, so that fraction is the same thing as cosine squared theta d theta. And then I need to use the power reducing formula for cosine squared, which is 1 plus cosine of twice the original angle, so 2 theta, over 2 d theta. Then I'm going to pull that 2 out in front, leaving 5 square roots of 3 over 18, leaving the integral of 1 d theta, which is theta, plus the integral of cosine theta, cosine of 2 theta, cosine of kx, if you will, which is plus 1/2 sine of 2 theta plus c. Then I don't know anything about double angles in this particular problem, so I'm going to need to rewrite sine of 2 theta in terms of theta. I'm going to use the double angle formula for sine, which is sine of 2 theta is 2 sine theta cosine theta. Okay. Now I need to go back up here and look for the equation where x is related to theta the first time. And so dividing both sides by square root of 3 means that the tangent of theta is x over the square root of 3. Draw a right triangle. this is theta, this is your right angle, tangent is opposite over adjacent. Using the Pythagorean theorem, that will end up being the square root of x squared plus 3. And so coming back down here to this problem. Oh, and one other thing, this also implies that theta is tangent inverse of x over the square root of 3. So this is 5 square root of 3 over 18 times tangent inverse of, let's see, that would rationalize to be x times the square root of 3 over 3. Okay, plus 1/2 times 2, of course, is 1. So I'm going to just drop that. And looking at my triangle, sine of theta is opposite over hypotenuse. So x over square root of x squared plus 3 multiplied by cosine of theta, which is adjacent over hypotenuse, plus c. Okay, so let's simplify. Distributing the number that's in front, this will be 5 square roots of 3 over 18 times tangent inverse of x square roots of 3 over 3 plus the 5 square roots of 3 times the square root of 3 in that last fraction will be 5 times 3, so that'll be 15 over 18. And 15 over 18 reduces to 5/6. So 5/6 times x over, and the product of those two radicals, since they're identical, will give us back the radicand, x squared plus 3 plus c. Okay, so let's carry that answer back into our problem now that we have this lemma done. Oops, went too far. Okay, so this is 5 square roots of 3 over 18 tangent inverse of x square roots of 3 over 3 plus 5x over 6 times the quantity x squared plus 3. And of course we'll pull in that c later. Technically I guess I should write that multiple times, but I'm going to cheat a little bit and avoid writing all of it. See, I did a lemma for this one, which meant I had all the work over to the side, whereas with the first one I did all of the work within the body of the problem itself. So anyway, I do want to write it down here. Now we have the next integral to work on. Guess this color is as good as any other. This one here. So let me move over a bit. Ooh, what happened? Just shot over. Lickety split. Okay. Well, I can see that I'm going to have problems. So they're going to have plus something because I don't have room to write it. I'm writing this, and then we'll have room here at the bottom. So plus something. That's a something. That's a something. Let me make it a box instead of a underline because then it looks like it's a subtraction or something. Okay, so let's see what goes in that box. If I let u equal x squared plus 3, then du is 2x dx. Actually, I want to go back and give myself a couple of those boxes back. So just a second, I want to erase a couple of these because there is a little bit of room now down here, so just erase them. Okay. Oops. All right. So that means I'm going to pull the 3 out. I don't have my du. I'll need a 2 in there. So I'll multiply outside by 1/2, which means in reality this is 3 over 2, because we pulled the 3 out and the 1/2 was created for this problem. So the 2x dx part of this, everything I'm circling, is my du. And in front of that, I've pulled the 3 out, so that leaves 1 over u. So this is 3/2 natural logarithm of the absolute value of u plus c, which we'll get to at the end. So this is plus 3/2 natural log of the absolute value of x squared plus 3. But because x squared plus 3 is never negative, the absolute value is superfluous, so I'll drop it. Okay, and finally, this one. Well, that one is an inverse tangent where a squared is 3, so a is square root of 3, and u squared is x squared, so u is equal to x, which is equal to a. Wait a minute, I started doing the wrong thing again. I did this before once. So u is equal to x, so du is dx, which we have, which means we're ready to rock and roll. And so this one will be plus something, making a triangle this time, just have a different shape. Okay, so what goes there is going to be oh, I'm sorry, that's a minus. Rats. Okay, well, I'm going to make this a negative something because of that minus. I messed that up. So plus negative 1 over a inverse tangent of u, which is x, over a, which is square root of 3. This is the last one, so I'm going to write plus c finally. So this is minus square root of 3 over 3 inverse tangent of x square root of 3 over 3 plus c, which I'll just carry down here. Okay, now I want you to pause this and see if you can simplify the final answer. All right, so wondering how you did with this simplification. Oh, there's a stray mark there. I guess I better get rid of it. So in looking at this, I do have some like terms. I see that this fraction and this fraction almost have the same denominator. This first fraction needs to be multiplied by 3 over 3 so that they have the same denominator. And combining those, we'll get 3 plus 5x over our common denominator of 6 times x squared plus 3. Okay, that's pretty good. And then I notice that I have a couple of different things that are something tangent inverse of the same item. So I need to combine those. They don't quite have the same denominator, so I'm going to have to multiply this one by 6 over 6 so that they have the same denominator, 1/18. So I'll have 5 square roots of 3 minus 6 square roots of 3, which is minus a single square root of 3 over the denominator 18, tangent inverse of x square root of 3 over 3. And then the only natural logarithm I have there is this one. So it just stays the same because there's nothing to combine with it. Plus C, and we're done. So that is the last line of that. And whew, boy, that was a super problem. It involved a lot of different things. And again, when I give you a super problem like this, generally it's good because it reviews a lot of concepts, so you get to see some things again that you have seen a couple of times, but one more time doesn't hurt. And it is not going to be, though, a test problem. I really don't want you to get too concerned about that. So I need to draw a line in here in case you look at this later and look back at it and go, oh my gosh, that is just so mixed up with that. I tried to avoid it, but oh well. Did the best I could. This is a really long, hairy, nasty problem. So the good thing is we reviewed a lot of stuff, and but it was very, very tough. Okay, so that's the end of this one. I will see you in class.